Eye color or eye color is a polygenic phenotypic character determined by two distinct factors: the pigmentation of the eye's iris and the frequency dependence of the scattering of light by the turbid medium in the stroma of the iris. In humans, the pigmentation of the iris varies from light brown to black depending on the concentration of melanin in the iris pigment epithelium, the melanin content within the iris stroma, and the cellular density of the stroma. The appearance of blue and green, as well as hazel eyes, results from the Tyndall scattering of light in the stroma, a phenomenon similar to that which accounts from the blueness of the sky called Rayleigh scattering. Neither blue nor green pigments are ever present in the human iris or ocular fluid. Eye color is thus an instance of structural color and varies depending on the lighting conditions, especially for lighter colored eyes. The brightly colored eyes of many bird species result from the presence of other pigments, such as pteridines, purines, and carotenoids. Humans and other animals have many phenotypic variations in eye color. The genetics of eye color are complicated, and color is determined by multiple genes. So far, as many as 15 genes have been associated with eye color inheritance. Some of the eye color genes include OCA2 and HERC2. The earlier belief that blue eye color is a simple recessive trait has been shown to be incorrect. The genetics of eye color is so complex that almost any parent-child combination of eye colors can occur. However, OCA2 gene polymorphism, close to proximal 5' regulatory region, explains most human eye color variation. Genetic determination. Eye color is an inherited trait influenced by more than one gene. These genes are sought using associations to small changes in the genes themselves and in neighboring genes. These changes are known as single nucleotide polymorphisms, or SNPs. The actual number of genes that contribute to eye color is currently unknown, but there are few likely candidates. A study in Rotterdam found that it was possible to predict eye color with more than 90% accuracy for brown and blue using just 6 SNPs. There is evidence that as many as 16 different genes could be responsible for eye color in humans. However, the main two genes associated with eye color variation are OCA2 and HERC2, and both are localized in chromosome 15. The gene OCA2, when in a variant form, causes the pink eye color and hypopigmentation common in human albinism. Different SNPs within OCA2 are strongly associated with blue and green eyes, as well as variations in freckling, mole counts, hair and skin tone. The polymorphisms may be in an OCA2 regulatory sequence, where they may influence the expression of the gene product, which in turn affects pigmentation. A specific mutation within the HERC2 gene, a gene that regulates OCA2 expression, is partly responsible for blue eyes. Other genes implicated in eye color variation are SLC24A4 and TEER. Blue eyes with a brown spot, green eyes, and gray eyes are caused by an entirely different part of the genome. Classification of color. Iris color can provide a large amount of information about a person, and a classification of colors may be useful in documenting pathological changes and determining how a person may respond to ocular pharmaceuticals. Classification systems have ranged from a basic light to dark description to detailed gradings employing photographic standards for comparison. Others have attempted to set objective standards of color comparison. Eye colors range from the darkest shades of brown to the lightest tints of blue. To meet the need for standardized classification, at once simple yet detailed enough for research purposes, Sedden et al. Developed a graded system based on the predominant iris color and the amount of brown or yellow pigment present. There are 3 pigment colors that determine, depending on the proportion, the outward appearance of the iris, along with structural color. Green irises, for example, have blue and some yellow. Brown irises contain mostly brown. Some eyes have a dark ring around the iris called a limbal ring. Eye color in non-human animals is regulated differently. For example, instead of blue as in humans, autosomal recessive eye color in the skink species Corycius ebrita is black, and the autosomal dominant color is yellow-green. As the perception of color depends on viewing conditions, so does the perception of eye color. Changes in eye color. Most babies who have European ancestry have light-colored eyes before the age of 1. As the child develops, melanocytes slowly begin to produce melanin. Because melanocyte cells continually produce pigment, in theory eye color can be changed. Most eye changes happen when the infant is around 1-year-old, although it can happen up to 3 years of age. Observing the iris of an infant from the side using only transmitted light with no reflection from the back of the iris, it is possible to detect the presence or absence of low levels of melanin. An iris that appears blue under this method of observation is more likely to remain blue as the infant ages. An iris that appears golden contains some melanin even at this early age and is likely to turn green or brown as the infant ages. Changes of eye colors during puberty, early childhood, pregnancy, and sometimes after serious stroma.The represent cause for plausible argument to state that some eyes can change, based on chemical reactions and hormonal changes within the body. Studies on Caucasian twins, both fraternal and identical, have shown that eye color over time can be subject to change, and major demelanization of the iris may also be genetically determined. Most eye color changes have been observed or reported in the Caucasian population with hazel and amber eyes. Eye color chart. Carlton Kuhn created a chart by the original Martin scale. The numbering is reversed on the scale below in the Martin-Schultz scale, which is used in physical anthropology. Light and light mixed eyes. Pure light 16, pure light blue 15, gray. Light mixed in Martin scale 14, very light mixed 13 to 12, light mixed. Mixed eyes, mixture of light eyes with brown when light and brown appearance is at the same level. Dark and dark mixed eyes, dark mixed 6 to 5 in Martin scale. Brown with small admixture of light, dark 4 to 1 in Martin scale. Brown and very dark brown. Amber eyes are of a solid color and have a strong yellowish golden and russet, coppery tint. This may be due to the deposition of the yellow pigment called lipochrome in the iris. Amber eyes should not be confused with hazel eyes. Although hazel eyes may contain specks of amber or gold, they usually tend to comprise many other colors, including green, brown and orange. Also, hazel eyes may appear to shift in color and consist of flecks and ripples, while amber eyes are of a solid gold hue. Even though amber is considered to be like gold, some people have russet or copper-colored amber eyes that many people mistake for hazel. Though hazel tends to be duller and contains green with red, gold flecks, as mentioned above, amber eyes may also contain amounts of very light goldish gray. The eyes of some pigeons contained yellow fluorescing pigments known as pteridines. The bright yellow eyes of the great horned owl are thought to be due to the presence of the pteridine pigment xanthopterin within certain chromatophores located in the iris stroma. In humans, yellowish specks or patches are thought to be due to the pigment lipofuscin, also known as lipochrome. Many animals such as canines, domestic cats, owls, eagles, pigeons and fish have amber eyes as a common color, whereas in humans this color occurs less frequently. Blue. There is no blue pigmentation either in the iris or in the ocular fluid. Dissection reveals that the iris pigment epithelium is brownish-black due to the presence of melanin. Unlike brown eyes, blue eyes have low concentrations of melanin in the stroma of the iris, which lies in front of the dark epithelium. Longer wavelengths of light tend to be absorbed by the dark underlying epithelium, while shorter wavelengths are reflected and undergo Rayleigh scattering in the turbid medium of the stroma. This is the same frequency dependence of scattering that accounts for the blue appearance of the sky. The result is a Tyndall blue structural color that varies with external lighting conditions. In humans, the inheritance pattern followed by blue eyes is considered similar to that of a recessive trait. In 2008, new research tracked down a single genetic mutation that leads to blue eyes. Originally, we all had brown eyes, said Iberg. Iberg and colleagues suggested in a study published in Human Genetics that mutation in the 86th intron of the HERC2 gene, which is hypothesized to interact with the OCA2 gene promoter, reduced expression of OCA2 with subsequent reduction in melanin production. The authors suggest that the mutation may have arisen in the northwestern part of the Black Sea region, but add that it is difficult to calculate the age of the mutation. Blue eyes are common in northern and eastern Europe, particularly around the Baltic Sea. Blue eyes are also found in southern Europe, Central Asia, South Asia, North Africa and West Asia. In West Asia, a proportion of Israelis are of Ashkenazi origin, among whom the trait is relatively elevated. The same DNA sequence in the region of the OCA2 gene among blue-eyed people indicates they may have a single common ancestor. DNA studies on ancient human remains suggest that light skin, hair and eyes were present at least tens of thousands of years ago on Neanderthals, who lived in Eurasia for 500,000 years. Blue eyes were present in a wide geographical range by the Bronze Age, though there are too few skeletons to estimate frequencies. A hunter-gatherer dating to approximately 5000 BCE at the Lebrana Arentero site in Leon, Spain, had blue eyes, brown skin tone, and white DNA haplogroup C6. DNA testing performed on ancient Scythian skeletons found that light eye colors were already present during the Bronze and Iron Ages in the Siberian Krasnoyarsk region. 10 out of the 11 subjects carried Y DNA R1A1, most commonly found today in Eastern Europe and South Asia. A 2002 study found that the prevalence of blue eye color among the white population in the United States to be 33.8% for those born from 1936 through 1951, compared with 57.4% for those born from 1899 through 1905. As of 2006, 1 out of every 6 people, or 16.6% of the total population, and 22.3% of whites, has blue eyes. Blue eyes are continuing to become less common among American children. Blue eyes are rare in mammals. One example is the quite recently discovered marsupial, the blue-eyed spotted cuscus. The trait is hitherto known only from a single primate other than humans, Sclatus lemur of Madagascar. While some cats and dogs have blue eyes, this is usually due to another mutation that is associated with deafness. But in cats alone, there are 4 identified gene mutations that produce blue eyes, some of which are associated with congenital neurological disorders. The mutation found in the Siamese cats is associated with strabismus. The mutation found in blue-eyed solid white cats is associated with deafness. However, they are phenotypically identical, but genotypically different. Blue-eyed white cats where the coat color is not strongly associated with deafness. In the blue-eyed Ohosazils breed, there may be other neurological defects. Blue-eyed non-white cats of unknown unknown genotype also occur at random in the cat population. Brown in humans. Brown eyes result from a relatively high concentration of melanin in the stroma of the iris, which causes light of both shorter and longer wavelengths to be absorbed. Dark brown eyes are dominant in humans, and in many parts of the world, it is nearly the only iris color present. Dark pigment of brown eyes is common in East Asia, Southeast Asia, Central Asia, South Asia, West Asia, Oceania, Africa, Americas, etc., as well as parts of Eastern Europe and Southern Europe. The majority of people in the world overall have dark brown eyes. Dark brown is often found in the Semitic people, among Jewish and Arab populations in the Middle East. Light or medium pigmented brown eyes can also be commonly found in South Europe, among the Americas, and parts of Asia. Light pigmented brown eyes are sometimes referred to as honey eyes. Gray like blue eyes. Gray eyes have a dark epithelium at the back of the iris and a relatively clear stroma at the front. One possible explanation for the difference in the appearance of gray and blue eyes is that gray eyes have larger deposits of collagen in the stroma, so that the light that is reflected from the epithelium undergoes scattering rather than Rayleigh scattering. This would be analogous to the change in the color of the sky. For the blue given by the Rayleigh scattering of sunlight by small gas molecules when the sky is clear, to the gray caused by scattering of large water droplets when the sky is cloudy. Alternatively, it has been suggested that gray and blue eyes might differ in the concentration of melanin at the front of the stroma. Gray eyes are most common in Northern and Eastern Europe. Gray eyes can also be found among the Algerian Sharia people of the Oris Mountains in northwest Africa, in the Middle East, Central Asia, and South Asia. Under magnification, gray eyes exhibit small amounts of yellow and brown color in the iris. Green. As in the case of blue eyes, the color of green eyes does not result simply from the pigmentation of the iris. Rather, its appearance is caused by the combination of an amber or light brown pigmentation of the stroma, given by a low or moderate concentration of melanin, with the blue tone imparted by the Rayleigh scattering of the reflected light. Green eyes contain the yellowish pigment lipochrome. Green eyes probably result from the interaction of multiple variants within the OCA2 and other genes. They were present in South Siberia during the Bronze Age. They are most common in Northern and Central Europe. They can also be found in Southern Europe and Western Asia. In Ireland and Scotland, 14% of people have brown eyes and 86% have either blue or green eyes. In Iceland, 89% of women and 87% of men have either blue or green eye color. A study of Icelandic and Dutch adults found green eyes to be much more prevalent in women than in men. Among European Americans, green eyes are most common among those of recent Celtic and Germanic ancestry, about 16%. Green eyes are common in tabby cats as well as the chinchilla. Long hair and its short-haired equivalents are notable for the black-rimmed sea green eyes. Hazel eyes are due to a combination of Rayleigh scattering and a moderate amount of melanin in the iris's anterior border layer. Hazel eyes often appear to shift in color from a brown to a green. Although hazel mostly consists of brown and green, the dominant color in the eye can either be brown, gold or green. This is how many people mistake hazel eyes to be amber and vice versa. This can sometimes produce a multicolored iris, i.e. an eye that is light brown, amber near the pupil and charcoal or dark green on the outer part of the iris when observed in sunlight. Definitions of the eye color hazel vary. It is sometimes considered to be synonymous with light brown or gold, as in the color of a hazelnut shell. Hazel eyes are common throughout Caucasoid populations, in particular in regions where blue, green and brown-eyed peoples are intermixed. Red and violet. The eyes of people with severe forms of albinism may appear red under certain lighting conditions owing to the extremely low quantities of melanin, allowing the blood vessels to show through. In addition, flash photography can sometimes cause a red eye effect, in which the very bright light from a flash reflects off the retina, which is abundantly vascular, causing the pupil to appear red in the photograph. Although the deep blue eyes of some people such as Elizabeth Taylor can appear violet at certain times, true violet-colored eyes occur only due to albinism. Spectrum of eye color. Medical implications. Those with lighter iris color have been found to have a higher prevalence of age-related macular degeneration than those with darker iris color. Lighter eye color is also associated with an increased risk of ARMD progression. A gray iris may indicate the presence of a uveitis, and an increased risk of uveal melanoma has been found in those with blue, green or gray eyes. However, a study in 2000 suggests that people with dark brown eyes are at increased risk of developing cataracts and therefore should protect their eyes from direct exposure to sunlight. Wilson's disease. Wilson's disease involves a mutation of the gene coding for the enzyme APase 7B, which prevents copper within the liver from entering the Golgi apparatus in cells. Instead, the copper accumulates in the liver and in other tissues, including the iris of the eye. This results in the formation of Kayser-Fleischer rings, which are dark rings that encircle the periphery of the iris. Coloration of the sclera. Eye color outside of the iris may also be symptomatic of disease. Yellowing of the sclera is associated with jaundice, and may be symptomatic of liver diseases such as cirrhosis or hepatitis. A blue coloration of the sclera may also be symptomatic of disease. In general, any sudden changes in the color of the sclera should be addressed by a medical professional. Anomalous conditions. Aniridia. Aniridia is a congenital condition characterized by an extremely underdeveloped iris, which appears absent on superficial examination. Ocular albinism and eye color. Normally, there is a thick layer of melanin on the back of the iris. Even people with the lightest blue eyes, with no melanin on the front of the iris at all, have dark brown coloration on the back of it, to prevent light from scattering around inside the eye. In those with milder forms of albinism, the color of the iris is typically blue but can vary from blue to brown. In severe forms of albinism, there is no pigment on the back of the iris, and light from inside the eye can pass through the iris to the front. In these cases, the only color seen is the red from the hemoglobin of the blood in the capillaries of the iris. Such albinos have pink eyes, as do albino rabbits, mice, or any other animal with a total lack of melanin. Transillumination defects can almost always be observed during an eye examination due to lack of iridial pigmentation. The ocular albino also lacks normal amounts of melanin in the retina as well, which allows more light than normal to reflect off the retina and out of the eye. Because of this, the pupillary reflex is much more pronounced in albino individuals, and this can emphasize the red eye effect in photographs. Heterochromia. Heterochromia is an ocular condition in which one iris is a different color from the other iris, or where a part of one iris is a different color from the remainder. It is a result of the relative excess or lack of pigment within an iris, a part of an iris, which may be inherited or acquired by disease or injury. This uncommon condition usually results due to uneven melanin content. A number of causes are responsible, including genetic, such as chimerism, Horner's syndrome and Waardenburg syndrome. A chimera can have two different colored eyes just like any two siblings can. man. Because each cell has different eye color genes, a mosaic can have two different colored eyes if the DNA difference happens to be in an eye color gene. There are many other possible reasons for having two different colored eyes. For example, the film actor Lee Van Cleef was born with one blue eye and one green eye, a trait that reportedly was common in his family, suggesting that it was a genetic trait. This anomaly, which film producers thought would be disturbing to film audiences, was corrected by having Van Cleef wear brown contact lenses. David Bowie, on the other hand, had the appearance of different eye colors due to an injury that caused one pupil to be permanently dilated. Another hypothesis about heterochromia is that it can result from a viral infection in utero affecting the development of one eye, possibly through some sort of genetic mutation. Occasionally, heterochromia can be a sign of a serious medical condition. A common cause in females with heterochromia is X-linked activation, which can result in a number of heterochromatic traits, such as calico cats, trauma, and certain medications, such as some prostaglandin analogs, can also cause increased pigmentation in one eye. On occasion, a difference in eye color is caused by blood staining the iris after injury.